Hello again, and thanks for joining me on another video here. Now in this video I'm going to use a Raspberry Pi and a couple of sound devices to make a multi-track recording setup. So I'll be able to record 4 channels of audio simultaneously. Okay, I'm using a Raspberry Pi just running off a 5-volt supply, not my PoE splitters that I usually run them on. And the sneaky ones amongst you will notice that the power light's not on most of the time. That means it's running under voltage, so it's not good, but it does the job still, regardless. Now, coming from that, I've got just these 2 M-Audio M-Track devices here. Okay, they're just USB sound cards, basically, that go into the Raspberry Pi with the USB. So that's all I'm running here. And I'm going to connect to this through wireless and do everything remotely. Right, I'm just going to very briefly talk about the difference between unbalanced and balanced audio cables. Now, unbalanced is what most people generally use, and it's like this RCA connector here, where you'd have a signal ground and the actual signal carrier in the middle. Okay, and that's the same as headphone sockets too. So use normal headphones that have a ground and they just have 2 signals, one for the left and right. Okay, what that means is you have your ground reference, which is the outer one, the shield, okay? And then you have the actual signal that we're interested in. Now it's AC, so it goes positive, negative, positive, negative. Okay, most of you are aware of that, but what it really means is in reference to the ground, which is sort of the center level, there's times when the voltage can be positive and negative with respect to the ground. Okay, with balanced audio, it works a little bit differently. You would have the same thing here, you have a ground reference, but instead of just, I'll actually mark the reference there. Instead of just having the signal, I'm trying to do exactly like the other one, it also has the exact same signal, but in the opposite polarity. Okay, so that's why on a balanced cable, you'll have 3 pins like this XLR connector, which is pretty common in studio gear. So with an unbalanced cable, you just have the ground reference on the outside and 1 signal carrier. Okay, with a balanced audio connector, you have a ground and you have a positive version of the signal and a negative version. Now, there's a reason for that. If some unwanted noise, and there's always unwanted noise in a signal chain, if some unwanted noise comes in and gets induced onto this signal, this red bit here is the signal we want, but let's say we get some little high frequency noise over it as well. Okay, that will come through at the amplifier at the other end. It'll see our signal that we wanted, but we'll also get the noise and we'll get that amplified as well. With balanced though, the idea is if you have noise that comes in to this particular signal, theoretically, hopefully, the same noise that's there will come into the other inverse signal as well. So let's say, it might be hard to draw, but let's say it goes positive here, negative, positive, negative, positive, negative, positive. Okay, let's say that little bit of extra signal was induced. Okay, so now instead of perfectly clean, we've got this modulated interference. Okay, now theoretically, if the same happened on the other side, so as it's going positive here with noise, it's going to be really hard to draw, but okay, I hope you can see where I'm going with this because it's not easy to draw this. The idea is as it's positive here, okay, this is noise we don't want on our nice signal. It also induced the same positive interference on our inverse wave. So at this next point, where it's the negative part of the noise cycle, it's also the negative part of the noise cycle on here. So these at least match. So when the noise comes in positively, it comes in positively on both sides. When it comes in negatively, it comes in negatively on both sides. Now that's actually what we want, because our original signal, which you can see underneath, the main part, obviously the signal to noise ratio is very high, you'd hope. Our signal is going up here and our inverse is down here. but noise comes in the same on both sides. So it's positive when it's coming in on the red, and positive when it's coming in on the green. Negative, negative, positive, negative. So the noise also AC, but it's the same phase on both sides. Now when we feed that into an amplifier, what we have is an amplifier that has a positive and negative input. Okay, so when our green signal here comes in, it's positive and it goes in positive. So let's say it's at plus 1 volt here or whatever. Plus 1 volt, and down here it's minus 1 volt, just for instance. When it comes in positively, hits the positive side of the op amp, the operational amplifier, it has the signal of 1 volt sort of thing internally. The negative portion, or the negative version, which is exactly the same but negative, it comes into the negative side. Now 2 negatives make a positive, so that also comes in as 1 volt. So positive 1 volt. So together we get 2 volts worth of good signal, the signal that we want. Okay, so our original big sine wave here, just for instance, is now nice and strong in the amp. But what about the noise? Well, the noise, if you remember, had the same phase on both sides. So when it was positive on the other side as well. So that carries all the way through here if I had drawn it. Okay, so let's say the noise is positive at the point where it hits the amp. It's also going to be positive on that side. Now when it goes into the amp, sure, the noise comes in as positive 1 amount of noise, but the same phase is now hitting the negative side. So that's a negative amount of that noise. So that noise gets cancelled out. So by doing that, we can get our signal twice as strong because we've got 2 copies of it essentially. And when they get to the op amp, the positive phase goes into the positive side, the negative phase goes into the negative, 2 negatives make a positive, they add up, you've got twice the signal. That's the strong signal we want. But the noise that we don't want, which is the same phase, and that's the key, the noise is the same phase hitting the inputs of these op amp. So you've got the plus version of the noise and the negative version of the noise gets cancelled out. Okay, so that's the benefit of using balanced audio compared to unbalanced, because unbalanced, the noise comes in and everything just gets amplified at the end. So you amplify the noise as well. So what I'm going to set up uses balanced audio sound cards with balanced microphones to get the best sound I can into the Raspberry Pi. So we'll go back to that now. Okay, now the Raspberry Pi has no recording device built into it, okay? But I've connected these 2 M-Track audio devices. So I'll just have a look at what's available on the Raspberry Pi. First for playback, okay? So if I just use A-Play-L, we can see the 3 sound cards. Okay, card 0 is the internal one. Okay, that's the Broadcom one. So it can play back obviously from the Raspberry Pi. And I've got 2 extra ones. I've got card 1, which is one of the M-Tracks, and card 2, which is the other M-Track. Now that's for playback. If I do a similar thing to show recording, A-Record-L, we only have 2 because the Raspberry Pi itself can't record. So we have card 1 is one of the M-Tracks, and as we know, card 2 is the other M-Track. Okay, so if I start Audacity, just to show you how that looks when you try to record something on a program, I'll just bring that up here. Now, I'm just showing this on Windows, but it's a remote session to the Raspberry Pi. So it's running on the Raspberry Pi. Now, the key here is if I choose the audio input device, I have 2 options, and that's the 2 M-Tracks. So each one of those is only 2 channels. Okay, so if I pick one and then just start recording, I have the left mic and the right mic, and that's about it. Okay, so that's pretty standard, 2-channel stereo, and that's it. What I'm going to do now is make a pseudo card which has inputs from all 4 as one device. Okay, so I'll do that now. What I'm now going to do is show you a file that I've put in called .asoundrc. Now, it contains this. I'll go through it with you. I'm making a new device basically, and I'm calling it multitrack. That can be called whatever, I'm just calling it multitrack. And what I'm doing here is defining some things. Now, the slave device, slave A, is hardware 1. Now that was the first M-Audio adapter that I have, okay? And it has 2 channels, left and right, we know. And I'm defining another slave B, which is the same sort of thing, except it's hardware 2. Remember we saw in A record, hardware 2? We're defining the second device here that also has 2 inputs. Now I'm going to bind that to make the 4-channel device. So bindings for the first binding, which is our first channel of my 4-channel one that I'm setting up, is slave A, which is the first one, and channel 0, so the left. The next one is same, slave A, this time channel 1, which is the right. For input 3, the third input, which is number 2 because they start at 0. Slave B, which is this adapter, and channel 0, which is the left. And for the last track, it's also slave B, channel 1, which is the right. So altogether, I have a new sound device called multitrack that has 4 inputs that I've just mapped. So given that file, just because it exists there, now when I run Audacity again, things will be a little bit different. Okay, so now I've got Audacity running. Where I select the input adapter, I now have an extra option here called multitrack. And for the channels, I can pick 4. So now if I record on that, I go to the microphones, go microphone 1, microphone 2, microphone 3, microphone 4. You can see when I spoke into each channel, there's microphone 1, microphone 2, microphone 3, and microphone 4. Okay, so that's how we can do it in Audacity. Now that's all good and well if you want to use Audacity, but I don't particularly like it, to be honest. But also, it's not very portable if you have to use a graphical interface. Now I want this to be portable, and I like using CLI stuff. So I've set up a little bit of a script to record the 4 channels and then split them into 4 stereo waves. So I'll show you how to do that. I have a little script here using a record, which is a simple recorder, and SOX to do the conversion. So it starts off with recording. The format is signed 16 little endian. That's just the format, so it's 16-bit essentially for this. 4 channels, the rate of 44.1 kilohertz, and the buffer time. Now the buffer, you want to put a bit of buffer in there. This is in microseconds, so I give it 5 seconds of buffer to stop any problems. The type is just a wave, and yes, you can have a 4-channel wave, that's not a problem. And the device is that multitrack one that I just created, and I'm just using whatever file name I type in as I do it. So once that records, and I just Control-C to get it out of the recording, it then proceeds to make the tracks. So it gets that wave file that I just made from the recording, the 4-track wave, splits it into 2-channel stereo, which will be the same left and right, but it gives me a stereo track to work with later. So it creates a file called channel 1, and it makes it from the first track that it recorded. And I just do that again for the next 3. So again, you just get the input that I created, that 4-channel wave at the start, telling it I want a 2-channel output, we'll call it that, and we'll use that second channel to create it, and so on. So now if I want to record just using CLI, I can just do record 16-bit, 44 kilohertz, and call it YouTube test. Okay? I'll just go microphone 1, microphone 2, microphone 3, microphone 4. Okay, Control-C out of that, and it just makes the four channels as we saw. And if you want to check the media info, YouTube tests channel 1, you can see it's created a stereo audio file from that channel, and there's 4 of them. Okay, so that's all good there. Now on that Raspberry Pi, I've set up Samba, so I've got a Windows file share on it. So back on the Windows machine here now, I can just go to that directory and all those files are there just for easy access. So now I've got Audacity running natively on Windows here, and I can just drag those files over to it and load them up. So let's go microphone 1, okay, 1, and just drag them all in. They're all going to be separate stereo tracks, okay? So all together, you can just, let's go microphone 1, microphone 2, that's what I recorded, microphone 3, microphone 4. So everything's in time, but I've now got separate stereo tracks to work with, so I can do effects and you know, whatever you want to do. So that gives me a portable recording setup because I can run the Raspberry Pi off anything, and I've got balanced audio input going to it, and I have 4 channels to record. All right, now here's the total setup. The 2 audio devices plugged into the Raspberry Pi. Now, if I want that portable, I can just use one of these 5-volt batteries here, power the Raspberry Pi from that, turn that on, and that's booting up. Okay, and that will give me a completely portable setup that I can just take anywhere to record decently. One thing of note though is I have to boot the Raspberry Pi up before I turn the 48-volt power on for the microphones, otherwise these sound cards have trouble. But that's no big drama. Once it's booted, that's fine. And running off the battery here, I do have the power light constantly on the Raspberry Pi because this battery gives good power. And now I have a portable setup ready to take anywhere. All right, so there it is, a completely self-contained recording setup using battery powered here for the Raspberry Pi, balanced inputs on the sound devices, 4-track recording, power for the mics. And if you're out in the middle of nowhere, if you want to record, you can just use your phone as a hotspot and then just SSH to the Raspberry Pi, to run a single command and do your recording. So that's what I've got. Now we'll see what I can actually do with this now. Okay, I've just put the microphones around the drum kit here. Probably not in the best spots, but just to show the concept. Got one on the snare, one over near those hi-hats there, one on the floor over there, and one up in the air. And they just go to the 4 inputs as shown. So I might just have a little tap of the drums and see what I can do. Okay, now back at the computer, I've just loaded those 4 stereo tracks into Audacity as a multi-track. So altogether, I've got the drums. But now obviously I can solo just, say, the kick drum. And work on the sound of the kick to get that how I want. And one of the mics is on the snare, so mainly the snare there. And of course, a hi-hat that I had, and all together. Okay, so as you saw, portable, multi-track recording. So I might have some more fun with this. Yeah, I've just thrown a few microphones around the piano. I'll see how this goes as well. I'm no expert at this, but I've just tried one down the low end, one at the high end, one in the center, and one up here for the overall. So I'll see how that goes.